Okay, we're going to have a look now at bonding between chemicals, and we're going to look at both types of bonding in one go. We're going to look at covalent bonding and we're going to look at ionic bonding. Okay, so let's start off. This is just a little diagram just to show you. So first of all, we've got chlorine. Now chlorine is in group 7, which is over on the far right, just inside the periodic table. Now if he's in group 7, remember he's got 7 electrons in his outer shell. Now atoms don't like to have gaps in their outer shell, and this is why they can bond with other chemical elements to form new chemicals. So because chlorine has got 7 particles in its outer shell, it really likes to join with somebody. So here we could use hydrogen, because hydrogen has only got 1 particle in its outer shell. Okay, so we could actually join those together. Now if you look here, chlorine and hydrogen, when they join together, apart from the fact that chlorine becomes chloride, this becomes hydrogen chloride. Okay, remember on its own it's an ion, and when it's joined together it's an ide. Now this is a covalent bond, and we know that because what they're doing is, first of all, they are both non-metals, and secondly they are sharing electrons, and those are the 2 main features of a covalent bond: non-metals, and they are sharing electrons. Okay, so let's have a look then. Here we've got chlorine, as we've just said, and chlorine is in group 7, and then we've got Sophie, the sodium, who is in group 1. So if chlorine has got 7 and sodium has got 1, again we know this is going to make a really good bond. But this is a different bond this time, because what's going to happen here is, because we've got sodium, which is a metal, and because we've got chlorine, which is in group 7 and is a non-metal, they carry out something called an ionic bond. And you can see this is different, because for this one what happens is the electron is given away. So it means that Sophie's quite happy now, because she's lost that 1 electron in her outer shell, meaning her next shell down that's got 8 electrons in it is nice and full, and she's very happy. And then our little friend here, the chlorine, has gained an electron and is very happy as well, because he's got 8, and so they are both part of an ionic bond. Notice they are both in these rather large brackets, and then they've got a plus and a minus by the side. Now this is what you would have to do if you were doing this in an exam question. An ionic bond has to go into these brackets. And what the positive and the negative mean, you can either think of it one of 2 ways. First of all, the chlorine has gained an electron. So you could think, there's one way you could think, oh, if it's gained an electron, then it's the opposite and it's a negative. Or if you want the scientific reason, it's because electrons are negatively charged, and so the chlorine has gained a negative, which is why you've got the negative on the outside. Now if an element had gained 2 electrons, it would be 2 negative, or 3, it would be 3 negative. Okay, so here then are some common examples of a covalent bond. Okay, so the first one you'll notice, and you should be able to work out that that is hydrogen, because it's only got 1 shell, it's got 1 electron in its outer shell, and when they join together they are sharing their electrons, and it fills up their outer shells. Now the thing we use is these things called dot and cross diagrams, and the reason we do that is so that we can easily see which elements have come, which electrons have come from which elements. Okay, so for this one, water for instance, you'll see oxygen has got electrons. It's got 8 electrons, so it's got 2 in its first shell, and then it's got 6 in its outer shell, meaning it's got 2 gaps. So oxygen will join with hydrogen. They are both non-metals, so it means that it will be a covalent bond, and you'll see one hydrogen is joined on one side and the other is joined on the other side. Oxygen, if we looked at oxygen, and we'd have one with dots, one with crosses, and when we join them together to make O2, you'll see that that's how they share. Okay, here's some more for you to see. N2. Methane, the gas that comes out of the Bunsen burners, you can see CH4. So it's 1 particle of carbon and 4 particles of hydrogen. Ammonia, NH3. Carbon dioxide, CO2. All very common covalent bonds because they are all sharing. So if we look at ions then, and what happens there, an ion is formed when an atom gains or loses electrons and becomes charged. And remember, that's what I said about the plus and the negative. And you may be asked to give a definition of what an ion is. So it's when an atom gains or loses electrons and becomes charged. Okay, so if we take away the electron, we're left with just a positive charge. So that's why we have the positive on the outside. So again, looking at ionic bonding, but using a diagram, you can see it's all in brackets with a plus and a minus. However, there is a slight mistake on there because we still need to have dot cross diagrams. One has to have dots, the other one has to have crosses. Okay. So here's some examples of ionic bonds. We've got magnesium chloride. So you've got 1 magnesium and 2 chlorides. So if you had to join them as an ionic bond, this is what you'd see. The magnesium has lost 2 of its electrons because they filled up the chlorines, and it means you've got 2 plus, whereas the chlorines, because there were 2 particles of them, they've gained 1 each, so it's only got 1 negative. It's a bit like in maths when you put x plus y, you don't write 1x plus 1y. Same in science, if there's only 1 of them, you just put a minus or a plus. Don't forget again, a chlorine on its own, join it together with something, it becomes a chloride. Okay, calcium oxide, again another example. 1 particle of calcium, 1 particle of oxygen. The calcium has given away 2 of its electrons to fill up the outer shell. Okay, you may be asked to talk about giant structures, and this is to do with how the well, where you'd see them in everyday life, really. Diamond is a giant covalent structure. Okay, then you've got sodium chloride, which is a giant ionic lattice. Okay, and then you've got graphite as well, and graphite and diamond, you should know, are from carbon. Okay, so please remember the difference between ionic bonding and covalent bonding. Ionic bonding is between a metal and a non-metal. It's about giving the electrons away. You put a bracket around the outside, and then you write down what the charge is, whether it's positive or negative, and how much it's gained or lost. A covalent bond is where they share electrons, and this is between non-metals.